Today, Academic Daddy will be teaching you everything you need to know on organic chemistry. Now, what is organic chemistry? Organic chemistry is the chemistry of carbon. We know that in the periodic table, carbon is number 6. That means the atomic number of carbon is 6, which means that carbon, we have its K shell. Using Bohr's atomic model, we have its K shell 2. Then you have 1, 2, 3, 4. That means it needs 4 electrons to attain octet structure. So it's in a position of gain or lose. That is why it does not form ionic bond. But what it does is to form what we call covalent bond. And this type of covalent bond is called dative or coordinate covalent bond, where hydrogen will now come. Only hydrogen will come, bring 4 of its atom. 4 of its atom. Hydrogen. When hydrogen bond with this, you now get a situation whereby this attain octet structure. And any covalent bonding where one atom donates all the electron is called coordinate or dative covalent bonding. So this is what leads us to a special type of compound called hydrocarbon. Hydrocarbon chemistry. So hydrocarbon is simple as the name implies, the chemistry of hydrogen and carbon. Chemistry of hydrogen and carbon. And we know that this is a non-polar covalent bonding. This is a non-polar covalent bonding because it has 4 electrons, 4 of this. So they are equal. The positive and negative, they are equal. They cancel out very well, such that this is no more electropositive, this is no more electropositive, or this is no more electronegative, this is no more electronegative. But whenever you have a situation like, let's say you have HF, fluorine is more electronegative, so it will turn this hydrogen to become partially positive. This one will be partially electronegative, more electronegative. We say that this type of bonding is polar bonding, but today we are focusing on organic chemistry, and that is chemistry of hydrogen and carbon, that is hydrocarbon, and it is more of a non-polar bonding. So let's get to it. So any straight chain hydrocarbon is called aliphatic hydrocarbon. And if you know this, we have alicyclic, we have the aromatic, but we are focusing on the aliphatic before the cyclic and then the aromatic. So first, we know that there's something called alkene. We have the alkene, and alkene simply means straight chain. I don't mean chain like this. This is like this. Now, there's another one called alkene. This means double bond. In English, you call it alkene, but in chemistry, we call it, when we hear double bond, we know it means, when we hear alkene, you know it means double bond. When we hear alkene, you know it means single bond. Then there's another one called alkyne. So this is like a family now. If you come to a family, you have, for example, Emmanuel, Ebenezer, Chidema, Ebenezer, Emanuela, Ebenezer. The Ebenezer is their surname. When you get into that family, and let's say you are part of the family members, or you get to the family, you're looking for someone, you have no reason calling any of them Ebenezer. You just say who you are looking for. So for that reason, whenever we are doing this, everything that has to do with arc, we don't mention it. Once you know the compound is having single bond, you just call it in. If you know the compound is just having double bond, you call it in. If you know the compound is having triple bond, you just call it in. The arc disappear. Now you need to know there's something called saturated. Any compound that has single bond is said to be saturated because all its hydrogen is complete. And any compound that has two bonds lost two hydrogens. It lost two hydrogens to gain this bond. So if you lose a hydrogen or you lose hydrogens, you become unsaturated. Now, for this triple bond to happen, hydrogen was lost here, hydrogen was lost, hydrogen was lost, hydrogen was lost. It lost four hydrogens to gain this triple bond. So this is also unsaturated. 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 So notice that this one has two more hydrogens. Then this one has two hydrogens less than this. And this one have two hydrogens less than this one. So this is what we call the homologous series. We are about to get to that. Now before we get to what we call homologous series, get to what we call homologous series, I need you to know that there's something called the family formula. So for alkane, the formula is CnH2n plus 2. So CnH2n plus 2. This is for alkane. While for alkane is CnH2n plus 2 minus 2. This is for alkane. So if you know this, that means that when I have two carbons, I'll have C2H2 times 2 plus 2. So this will give me C2H4 plus 2, which will give me C2H6. So this is 2 carbon, 8. Single bond, every hydrogen there is complete. In, so it is ethane. So for alkane, the homologous series is plus 2. Everything is complete. The formula for alkane is this. Now let's check alkane. Alkane is CnH2n plus 2 minus 2. So let's take it that you know that double bond starts with eth. There is no met in double bond. You can never hear methane. It's not possible. You have ethane, propane, butane, and the rest of them. So let's say I have 2 carbon. In double bond starts from 2 carbons. You can never have 1 carbon for double bond. So 2. That means I have H2. This N stands for number of carbon, 2 plus 2 minus 2. So this is going to be C2H4 plus 2 minus 2. This is something as C2H6 minus 2. So this is the sentence as saying that this is equals to C2H4, which is the sentence as saying C So when you count it, 1, 2, 3, 4. 1, 2, 3, 4. The carbons are complete. Every carbon must be bonded to 4 bonds. Every carbon must have 4 bonds because I showed you that combination when we started. So if you check it, we have 1, 2, 3, 4 hydrogens. It lost 2 hydrogens to gain this extra bond. So that is it. Now let's move to alkyne. Now for the alkyne, this is triple bond. Alkyne means triple bond. For the alkyne, we're simply going to have CnH2n minus 2. This is the family formula of alkyne, which means that if I have C2, 2 carbons, I will now have H2. Now, number of carbon is 2 minus 2. So that this becomes C2H4 minus 2, which is the same thing as saying C2H2. So, you need to know this. And this is the same thing as saying, this is the same thing as C triple bond for alkyne. Let's check it. 1, 2, 3, 4 for this carbon. 1, 2, 3, 4 for this carbon. So it's complete. So it lost 4 hydrogens to gain these 2 bonds. On every bond you have a hydrogen that has been lost. So you lost this to gain this. So that is that. And this is what we call the homologous series, the formula noting it. Now we'll move to knowing the family name, which is homologous series proper. Now you need to know this. Now when I have just carbon, this is called mates. When I have 2 carbons, I notice the question. I notice that the carbons I'm seeing there is 2. That is things like maybe this way, or this way, or this way, or for the fact, or this way. But for the fact that I'm seeing it and it's 2 carbons, and it's 2 carbons, this is called X. Now when it's 3 carbons, for example, this way, this way, this way, this is called prop. Just make sure you know the first 10 names of this carbon. When it's 4 carbons, is boots. When it's 5 carbons, is pants. Now when it's 6 carbon, when it's 6 carbon, is hex. When it's 7 carbons, is hept. Now when it's 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8, is oct. When it's 9 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9. When it's 9 carbons, is none. When it's 10 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is deck. When it's 10 carbon, is deck. Now, for a single carbon, all you have for a single carbon will always be single bond A. You can never find double bond on a single carbon. Now, if it's double carbon, if the carbon is 2, then I see a single bond. It means that this will now be A for single bond. But if I see double bond, it means that this will no longer be in, it will now be in for double bond. And if I see triple bond around this double carbon, it will now be I. It will now be I. The same thing applies if I see single bonds all through, it will now be propane. But if I see double bond at any point on this triple carbon, I see double bond, it will no longer be in, it will now be in. It will now end with in, propane. If I see triple bond around this, it will no longer be in, it will now be I. Now, if I see single bonds all through this, it will be butane. But if at any point I see double bond, it will no longer be in, it will now be in. If at any point I see triple bond, it will no longer be in, but I. Now, if I see single bonds on this, it will be A. But if I see double bond at any point here, it will no longer be in, but in. Now, what of a situation whereby I see a single bond and I see 2 double bonds? For example, situation where I see, like this case now, I see 2 double bonds. This will now be going this way. I will count 1, 2, 3, 4, 5. And we'll do more of this when we get to iambic nomenclature. 1, 2, 3, 4, 5. So I will now take the smallest number before the double bond. So this happened that if I'm going this way, I'm going this way. 2, 4. So this will now be pent 2. Separate numbers with comma. 4. Now because the double bond is 2, it will now be di. Separate number from letter using hyphen, di-in. Pent 2, 4, di-in. That will now be the name. So if I see this, everything single, it will be hexane. But if I see double bond at any point, it will no longer be hexane. It will now be hexane. Now, what if I see the double bond? Let's say somewhere. Notice that this one is 1, 2. So this happened at position 2. For this one, this is going to be but 2I. Yeah. What if I see this double bond? Let's say at this position. That means I'll now call this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you label up, forward, label down, backwards, then choose the smallest number before the thing happened. Whichever way we go, the smallest number is still 3. So I'll say 3, it happened, this is double bond, 3 in. So, and the longest carbon chain is hex, so it will be hex 3 in. Hex 3 in. That will be the name. So if you want to write it now, it will be hex 3 in. Hex 3 in. So knowing this now, I want you to do assignments. Name the remaining ones. When it's single bond, when it's double bond, when it's triple bond. Our next class, I'll be teaching you everything you need to know on skeletal structure. Naming this compound when it's a skeleton. This one we are doing is more of the structural. When it's structural, when it's expanded. I'll be teaching you the condensed form and the skeletal form of the naming hydrocarbon compounds.